learning problems, especially in reinforcement learning, need to interact with an environment. All the learning is based on interaction with an environment.
This is Hadrien Hendrikx, a PhD candidate at Inria in Paris, who's currently visiting EPFL and who did a master's work at EPFL on AI safety.
In some cases, when you are dealing with the real-life systems, you want to have control over this interaction. For example, with self-driving cars, the car will learn by driving and driving again and again. But you still want, at least at the beginning, but maybe after, to have a control, to be able to brake and to sometimes tell the car to do something specific, because it cannot learn all by itself. It's really a trial and error mechanism. So it will try things, and if the outcome is good, it will do it again, and if the outcome is bad, it will stop. But some outcome, well, you cannot afford to do some actions in the real world. The space of actions is constrained.
We talked more about reinforcement learning in a previous video, but with self-driving car, the problem speaks for itself. At some point, if you want to know how to drive, you need to take the wheel, and you'll be prone to make potentially catastrophic errors that are extremely hard to predict.
You can integrate that directly into the system at the beginning, but it's not always possible, and you can't always think of all the cases that can arise, all the situations you can be faced with. And so this is why in some systems you need the control of an operator, so the driver, for example, here, to stop the car in some specific situations that were not completely planned, or that were planned for, but that the system did not recognize.
Now, this sounds simple and easy, just stop the car right before it does something bad. So what's the problem?
And so the problem is that it's, as we said, it's learning all the time, and it will also learn from the interruptions, because interruptions for the system, it's just another element of the environment, and it has to react to these kind of elements.
In particular, interruptibility must be regarded as a kind of teaching signal.
It will bias the signal, because you want the car to learn as if you were not there. Because the goal of learning is to have something autonomous, and is to have something that you won't necessarily have to monitor all the time, or even to have something that you can monitor all the time. And if you're dealing with a learning system that you're interrupting, and if it learns that when it's in some situation you're interrupting him or it, then it will get a lower feedback, and it can learn that actually you interrupting it leads to a lower feedback.
And for a reinforcement learning agent, feedback is everything. And thus, if interruptions lead to rewards, then it will try to be interrupted. If interruptions lead to penalties, then it will try to avoid interruptions. This is because the only reinforcement learning AI's goal is the maximization of rewards.
It's not a bad agent, or it's not benevolent either. It's just trying to optimize a function that you have given it. And if to optimize the function, it has to stop you from interrupting it, it will do it, because that's what you told it at the beginning. It's just that you did not think of all the possible ways in which it could optimize it. And it can sometimes cheat, and this is called reward hacking. And it will do something that was completely unplanned, but that was actually in the design of the system. It's just that the design was flawed at the beginning. And in toy system, it's not a problem, because you can just turn it off and change the design and have something new that's working as intended. But in real world system, you cannot always change the design. So you want to have something that prevents reward hacking, and you want to have something, you want to be sure that interruptions are not treated as just another component of the environment, because if it's treated as just another component of the environment, it will try to avoid it. And you want your system to be completely neutral to interruptions. That the very definition of safe interruptibility is to be neutral to interruptions.
Now, it should be said that safe interruptibility is a bit irrelevant to many of today's AI systems. In fact, it is only relevant to systems that keep learning as they interact with their environment. But there's a good chance that such systems will be more and more numerous in the future.
Safe interruptibility only applies to systems that are learning online. So it only applies to systems that are constantly adapting to their environment, that are constantly reacting to changes and learning to adapt to these changes. And otherwise, you can just collect data and then learn on this data and release a system in the real world that will be interrupted and there will be no consequences, because if it's not learning in real time, then it will not adapt to these interruptions. So it's critically for systems that are learning online, and there are actually not a lot of these systems nowadays. There will be more and more, but as of now, I think most systems are trained before in the labs or in the industry, and then when people are satisfied with the results, they release the trained model. And so I think there is a bit of time before we see these constraints really enforced in real systems.
Having said this, just because safe interruptibility does not yet apply to most AI systems does not mean that we shouldn't be doing research on such problems right now.
When we get to these systems, we won't have time to do all the research in this field. It's good to start now, because it's also a complex question, and it's necessary to think about it before this really becomes an issue. It's really something that needs to be anticipated.
And yet, so far, there's a bit of a stigma about doing this kind of research, mostly because of the temptation to assimilate AI safety with cultural cliches.
I often hear people mocking a bit the field, saying it's a Terminator kind of thing, but it has more subtle effects, and I think it's really crucial for any system that's learning online and that can be interrupted, because it's not about preventing a machine from killing you. It's really about having algorithms for which you are, I won't say sure, but as sure as possible that they work as you intend they do, and that your actions have as predictable consequences as possible. And to me, it's really the base condition of all learning systems, is you want to reduce the uncertainty. And this is exactly what is aimed for safe interruptibility. Safe is not in the sense of safe for you or for your health. It's in the sense of consequences, whatever they can be, are controlled, and they are predictable as much as possible. It's part of a more global picture that's really developing these years, and that's attracting more and more attention, and I hope this will continue.
It doesn't matter what you want to do, you probably can't do it if you're destroyed. So it doesn't matter what the AI wants, unless it wants to be destroyed in some trivial case. But if the AI wants something in the real world and believes that it's in a position to get that thing, it wants to be alive. Not because it wants to be alive fundamentally. It's not a survival instinct or an urge to live or anything like that.
It's a knowing that it's unable to complete its its duty, would it be, almost?
Yeah, it's unable to achieve its goals if it's destroyed, and it wants to achieve its goals.
The main thing to guarantee interruptibility is to have algorithms that do not directly depend on the sequence of actions. So these algorithms are called off-policy algorithms,